Okay, we just leveled up and now we're on solving by factoring 2 because this takes it a step up a notch. So let's go for it. First off, let's review factoring by grouping by factoring the following polynomials. Okay, if you remember by grouping, we have to look at all 4 of these and realize that all 4 do not have something in common. So we're going to group the first 2 and the second 2, and we're going to just look at them. Well, we have a 2 times an x times an x, and we have a 3 times an x. So what do they have in common? They have an x in common. So we're going to say they have an x in common. Factors of 2x plus 3 were left over. Then we look at our 3 times 2 times x. And here we have a 3 times a 3. So what do they have in common? They have a 3. So they have a positive 3 in common. The factors left over were 2x and a positive 3. And we remember that that should happen because remember now we are doing distributive property again. So we distributed out the factor they had in common, which was an x and a 3. Now we are looking at the binomial they have in common. They have a 2x plus 3 binomial, and we are multiplying that by the factors that were left over. So that factored is this. Why do we do that? Because then we can go ahead and if need be, set this equal to 0 and figure out what values of x will make that equal to 0. Okay, so now we're going to go even further back and look at multiplying these binomials. Remembering that again, this 3x has to be multiplied through. So we get 3x squared plus 15x. That 4 has to be multiplied through. So we get plus 4x plus 20. And then we combine those like terms. We end up with 3x squared plus 19x plus 20. Okay, so multiplying those binomials will give us a polynomial. One thing that I want you to look at, realize how this is different than what we did last section. Notice there is a leading coefficient that's other than 1. So this is where we have to step up a little bit on how we are going to factor this because our factors are going to look like this. We are going to have a number that's outside here. So notice now our first term isn't just x times x to be x squared. Now there is going to be a number out there. That number does affect what is happening to our middle numbers because look at this. We have a 3 times a 5. That turns it into a 15. It's now no longer what times what gives us 20 and added together 19. That 3 is going to affect our answer. Because of that, now when we look at what times what, it's not just the 4. We have to look at it like this. What two numbers multiplied together give us 12 now? Last time, technically, we did do that because we took whatever number was out here and we multiplied it by a 1 that was out there, but it was always a 1. So we did just focus on that outer term. But now we have to go ahead and multiply the first and the last terms of the trinomial. So what two numbers multiplied together give us 12? And still the added together are going to give us 8. Okay? The difference is that, again, we have to look at those outside numbers. So we're still going to put together our factor sum. But again, our factor this time is 12. Our sum is 8. Let's go through it. 1 and 12, 13, a little too big. 2 and 6, which is 8, which is what we wanted. Okay, so here's the problem. Don't write, well, you could possibly write this down to show what happens. We can't just right away say, oh, I know it's 2 and 6, and I know it's x and x, because remember, that's not true. There's a 3 out in front of that x. So if we multiplied this together, we would get x squared plus 8x plus 12. Okay, that's wrong. So then maybe it's 3x plus 2 times x plus 6. Or it could be x plus 2 times 3x plus 6. Which one is it? Okay. This is where we're going to have to go a little bit extra step here. Okay. And with that, look at what happened right up here. Realize that still, no matter what number is out in front of our variable, we are still going to add together those two middle terms. Those two factors multiplied together are always going to give me that 19. So we're not going to go this way. We're not going to guess and check. We are going to use these to rewrite our two middle terms. So we are going to write these as a 2x and a positive 6x. And the way that we're going to do that is we're going to rewrite 8x like that, because we understand adding these two together gives us 8x. So rewriting him as 2x plus 6x does nothing to my factors. They're going to be the same. It's just I'm going to pull them apart to show you what happens. So I'm going to write 3x squared. I'm going to put plus 6x just for the sake of argument for just a second, and I'll explain why I did that in just a minute. 2x plus 4. Okay, did I change that problem? Nope. But you know what I did? I now have 4 terms that I can go ahead and factor by grouping. This is the fail-safe way to factor these correctly. Does it take a little bit of time? Yeah, but it is, again, fail-safe instead of guessing and checking and being very frustrated later. So let's go ahead and do that. What terms do they have in common? They have both the 3 and they have an x in common. Okay. That is the wrong color. I apologize. So they have a 3 and an x in common. What's left over? An x and a positive 2. Okay. I'm not going to go through all of the factoring anymore because hopefully we're pretty good pros at that. Here, what do these two have in common? They have a positive 2 in common. What's left over? An x and a positive 2. Okay, so with that, I see that they have both an x plus 2 in common. So I'm going to distribute that out. And I'm going to rewrite what's left over. And look at that, I was way off anyway, because that 6 doesn't even show up in here. So are we sure that we're right? Well, first our 3x squared. Outside is 2x plus a 6x is 8x plus a 4. We're correct. So this is a different concept than what we did in that last section. Okay, we're still dealing with our factors and sums, but from there we definitely go a different route. Okay, I do apologize that we're running out of room here. So 3, I'm going to have to do the really ugly, okay, this is one huge problem right here. I'm not going to spend this much room on this next one. Okay, again, I notice that I have a coefficient out in front of the x squared. So now I have to look at both of these two together. So when I do my factors and my sums, I know my factors are now negative 12. And I know my sum is 4. Okay, so what times what gives us negative 12 added together 4? Well, let's go ahead and try 2 and 6, knowing that one of those has to be negative. So negative 2 plus 6 is 4. There it is, because this is negative and that doesn't work. So what do we do with that? We are going to rewrite 4x as negative, or as 2x, well, as negative 2x and positive 6. Okay, why are we doing that? Because it's a fail-safe way that we can go ahead and factor by grouping and be on our merry way from there. So I'm going to, the only thing that I change is that middle term. We have 4x squared. I have plus 2x minus 6x minus 3. Okay, remember down here I switched it. The only reason I did that is because sometimes you'll realize that they do not have something in common, so you have to take out a 1. And we'll get there. I just didn't want to do that in the introduction. I wanted to make sure that we understood what we were doing. So again, the reason why I do that is now I have two binomials that I can split this up in and factor from there. Okay, so 4x squared plus 2x, what do they have in common? They have a 2 and an x. What's left over? A 2x and nothing. I got rid of it all, so I'm going to say plus 1. Okay, negative 6x minus 3, what do they have in common? They actually have a negative 1 in common. So I'm going to say they have a negative 1 and a 3. So they have a negative 3 in common. Okay, which leaves over a positive 2x. Negative 3 divided by negative 3 is a positive 1. Okay, so I'm glad that I said that because that's a good way of thinking of it. If you don't want to go through all those factoring, I took 4x squared, divided it by 2x, and this is what was left over. I took 2x divided by 2x, and this is what was left over, because technically we're dividing those terms. We saw it as factoring, but it's dividing, which is synonymous. Negative 6x divided by 3 is 2x. Negative 3 divided by 3 is a positive 1. Okay, we did have to distribute that negative out because, again, we had to have those like terms. So now we can go ahead and say we have 2x plus 1 as a like binomial, and we have 2x minus 3 that's left over. And I'm guaranteed that that is the correct answer. I don't have to go through and guess and check. I will tell you that was how I was taught, is guessing and checking. And some of these problems we spent about 15 minutes on, very frustrating. So when I learned this, I was ecstatic. Okay, so yes, it does take a little bit of time, but we are guaranteed the correct answer right away. Okay, now let's look at 4. Before we go anywhere, yes, I see that there's a coefficient out front. But I also glance a little bit ahead and I realize something. They all have a 2 in common. So can I take a 2 out? Can I factor a 2 out? Yes, I can. So if I factor a 2 out, I have x squared left over. 10x divided by 2 is a positive 5x. 12 divided by 2 is a positive 6. So why would I want to do that? Because look at this. Now my coefficient out in front of x squared is just a 1. So this goes back to what we did last chapter or last section, which is so much easier. With a coefficient of 1, I can focus on my factor and my sum. My factor should be 6. My sum should be 5. So let me go through my factors. 6 and 1 is 7. How about 3 and 2? 3 and 2 is 5. So there it is. So don't have to go through all of the factor by grouping. I know right away because there's a coefficient of 1. I have my 2 parentheses. I know my first terms are x because x times x is an x squared. I know I have a positive 3. I know I have a positive 2. The one thing I cannot forget is that 2 comes down here, okay, because I did distribute out a 2. So I threw that in there to, again, be really comfortable with understanding what we're doing with factoring. We're taking out what they have in common, and since they all had a 2, be nice to yourself, okay? If we did go through this, all of the crazy factoring, you could have got 2x plus 6 times x plus 2, which would have worked, okay? However, completely factored, that 2 should be taken out. Okay, so definitely a different concept, but again, we're going to do just kind of some drill and practice to make sure that we understand it. So go ahead and get out the notes and vocab for this section. Okay, objectives are to solve quadratic equations by factoring like we did last time, and then write those one variable quadratic equations to represent context. So again, the drill and practice, so when we get to those real world story problems, we know what to do. Again, I put this whole front page on there to show a different type of concept with those nice algebra tiles, the way that they do their factoring, the way that they group, which is the same way that I taught you. And again, the words in the example there. So a little bit more information in case you want to peruse that. Otherwise, we are heading straight to example 1. first thing that I see is that I'm factoring this trinomial. So I know in my mind that my end product is going to be two binomials multiplied together. Okay, then I go straight for this. I see that there is a leading coefficient that is a leading coefficient other than 1. So I know because of that, I have to multiply that leading coefficient by the constant. So my factor is now 28. So when I look at my factors and sums, 28 is the number that I have to multiply, and 29 is my sum. Okay, when that sum is bigger than the factor, almost guaranteed that it's 28 times 1 that you're going to use. Oh, whoops. So what is the sum of that? 29. Okay. So that does work. Okay. That means that, again, I am going to rewrite my 29x as 28x plus 1x. Okay. And the reason why I'm doing that is then I can look at it as factor by grouping. So I have 7x squared plus the 28x plus an x plus a 4. Then I'm going to focus on each one of these pieces. Okay, so let's go ahead and look at that. 7x squared plus 28x. They have a 7 factor in common. They have an x in common. So I'm going to say they have a 7x. That is an x plus 4 that's left over. X plus 4, do they have anything in common? They don't, except the factor of 1. So if there is nothing in common, you're going to have to take out a 1. They have a 1 in common. They have an x plus 4 left over. Because look at this. Now we see that they do have that common binomial of an x plus 4, and they have a 7x plus 1 left over. Okay, here arises the question of, did I have to put 28 first, or could I put 1 here? Okay, you could have actually put 1 here. Your answer is going to be backwards. Okay, that your like term is actually going to be 7x and a positive 1. So yes, it does work. I always try to group the two numbers that I know have something in common. So that's why I put that 28 with my 7, because I saw right away that they did have like factors. I realized that an x and a 7 did not. Okay, 28 and 4 do, but I saw right away that that would work a little bit better. All right, so let's keep moving on. We have got a coefficient bigger than 1, or a coefficient different than 1. So we are going to have to look at the factor of our leading coefficient and our constant, which is 54. Okay, so here we go with our factors and sums. Still setting this up the same way. I think I'm going to put this way over here so I can show you what I meant over here just one time. And then we'll move on with life. So I know that my factor has to be 54. My sum still is going to be the same. Okay, 54 is, if we divide that by 2, it's 27, which is a little bit bigger than 15. If we divide it by 4, that doesn't work. So why don't we go down to 9? So 9 and 6 multiplied together are 15. Okay, do I know my factors? Yep, a little bit, so that does help out. All right, so first time around, I'm going to write this with that 9 first. So 3x squared plus 9x plus 6x plus 18. So again, keep in mind what I'm doing. I am just pulling apart that 15x so I can factor by grouping. I'm going to write it again over here, so I'm going to do this problem twice with a different color if my pen works. I'm going to do 3x squared plus 6x plus 9x plus 18 to show you how this works. All right, let's go ahead and do some factor by grouping. So I realize they have a 3 and an x in common with an x plus 3 that's left over. Again, 3x squared divided by 3x, x. 9x divided by 3x, 3. I see these have a positive 6 left over, and I have an x plus 3 or they have a, I'm sorry, they have a positive 6 in common, and they have an x plus 3 that's left over. So look at this. We have an x plus 3 in common. We have a 3x plus 6 that's left over. Okay, look at this though. These actually have a 3 in common. So we could go even a step further and say that this piece right here has a 3 in common with an x plus 2 left over and an x plus 3. Okay, so looking at this one over here, I'm going to combine these, and I'm going to notice that these both have a 3 and an x in common, and I'm left with an x plus 2. These have a 9 in common, and I'm left with an x plus 2. So look at this. I'm definitely going a different route on this. Does that mean I'm going to get a different answer? Well, we'll find out. They have an x plus 2 in common. They have a 3x plus 9 left over. But remember, factoring, we can't have any known factors involved here. So these both have a 3 in common. And x plus 3 was left over. And then I'm going to write my x plus 2. So did I get the same answer? I have these written in different order. But yes, those are the same answers going two different routes. Okay, you want to know something even more fun? Look at this. What could I have done from the beginning, about 5 minutes earlier? I could have looked at all three of these and realized what? They have a factor of 3 in common. So before I even started this, what's the color I didn't use? Gray. I could have said they all have a 3 in common. So I'm going to distribute out a 3 with an x squared plus 5x plus 6 left over. And now I'm back to the easy type of factoring, that there's nothing out in front of that x squared. So I can say what times what gives me 6, added together 5. Well, hopefully those of us that are getting used to factoring, we know that 3 times 2 gives us 6 and added together 5. So this is x plus 3 and x plus 2, not forgetting the 3 that we distributed out. So look at that. 3 different ways to solve this problem, all getting down to the same answer though. So find the one that you want. Realize, don't debate, well, where should I put those numbers? Is there a special way? Usually not really. I mean, whichever way you are going to get the answer. All right, guided practice 1. Go ahead and give it a shot. Okay, 1A, looking at that again, that our factor is 30, our sum is 13. Go ahead. Again, I paired that 10 with 5 because I realized they're a good pair. Okay, I paired the 3 with 6 because they're a good pair. Once you get to 1B, again, realize that they all have a 2 in common. That doesn't help us as much as the one above here, but it does at least simplify the numbers a little bit so we can find some factors and sums. The only problem is don't forget about that too. So I did have them just tag along right here. You don't have to deal with this with the big brackets. Definitely don't distribute him back because again, factoring, we're trying to get all common factors out of there. So you could just leave him up here and remember when you finalize your answer, he is a factor in the problem. So make sure that you do include him. Okay, that one did have a negative in it, but I think we can handle negatives because we know how they work. So looking at example 2, we have that coefficient out front. Quickly looking, it doesn't look like we can get rid of anything. So again, our factor is 60. And our sum is negative 17. Okay. Okay, noticing that middle number is negative, I know my bigger number is going to be negative, so those are the only ones I'm going to worry about. Let's try maybe 2 and 30, and knowing my bigger number is negative. It's going to give me negative 28. That's a little too big. So let's go to 3. Let's try 3 and 20. Again, bigger number negative because that middle number is negative. Negative 17, there it is. Okay, so really the only difference here is knowing what to do with that negative. Okay, we're going to take that information and split apart our middle term, leaving our 3x squared b. positive 3x because I know definitely they'll work well together, a negative 20x, and a positive 20. Now let's do some grouping. Okay, looks like we have a 3 and an x in common. 3x squared divided by 3x is just an x. 3x divided by 3x is a 1. Okay. Do I have a negative 20 there? I do have a negative 20. So on this one, we have a 20 in common, a positive 20. We actually have a negative x here and a positive 1 that's left over. Okay, notice how this didn't work because we have that negative and there's no way that we can do an inverse there. Well, look at this. That negative in the middle with this being positive means that both of my numbers have to be negative. So actually this doesn't work because look at this. My factor has to be a positive 60 and look at this. We didn't have a positive 60. So we actually have to keep going with our factors. Okay. A mistake that actually does show you that if you get down to this, again, this is a fail-safe way of solving this. So if you get stuck, something happened. And that was it, that both of these have to be negative, or both of these have to be negative in order for that to be negative. So let's keep going because that didn't work. Let's try maybe a 5 and 12. Okay, both negative will give us a positive 60. Added together will give us a negative 17. So that's the negative 17 that we were looking for. Make sure we're picky with our factors or else we get stuck at a standstill. Okay. Good example of how that does catch something that's going wrong. So now let's use the correct numbers. We have 3x squared. Again, which number should I pair that with? Probably a negative 12. Minus 12x minus 5x plus 20. And let's see if this shows us that we are correct now. Okay, so it looks like we have a 3 and an x in common. We have an x minus 4 left over. Here, again, this is one thing that I'm looking ahead with. I want my first term to be positive and my second term to be negative. So what am I going to take out of here? I'm actually going to take out a negative 5. Because what is negative 5x divided by negative 5? A positive x. What is 20 divided by a negative 5? A negative 4. And that's what I needed right there. Otherwise, I would have had to keep going with that additive inverse, and that was an extra step. But now I do have an x minus 4 as a common factor, and I have 3x minus 5 as the factor that was left over. Okay, again, I did show you this because look at this. That is a fail-safe way. So as long as we understand our factors, knowing how am I going to make two positive numbers and add together a negative, we should be good to go. So notice the two different patterns here that these are both negative. This is a negative and a positive. Use what we know about that to go ahead and solve guided practice 2. Okay, biggest challenge on 2A is that when we were grouping, there wasn't anything that n and negative 1 had in common. So we do have to force that positive 1 factor out of there so we have something to combine with our second binomial. On 2B, realizing that there is a 5 in common, so I got rid of that 5 right away to deal with some smaller numbers. Also realizing that I had a positive factor and a negative sum, so I knew both of them had to be negative. Okay, then when I got down to factoring, in that second term, I thought ahead and realized that I needed a y minus 2 in order to have a factor by grouping. How was I going to get that? I would have to take out a negative 3 in order for that to happen. Once I got down to the bottom, I had to remember that 5 that I took out earlier. So that is part of my factor. Okay, so a lot of concepts going on here. Again, how much do I think you're going to see these type of problems? They might be out there. So just understand the concepts and be used to them. All right, with this one, a polynomial that cannot be written as a product of two polynomials with integral coefficients is called a prime polynomial. So sometimes there is absolutely no way to factor something. With these, they want us to struggle through them and be frustrated, but I'm actually going to show you again how to use our resources and graph these to check if they're prime or not. So go ahead and get out your graphing calculator. Okay, if you remember earlier when we were dealing with exponents, we graphed the equation to find the zero. That's what we're going to do here. It's not asking us to solve it, but if we did go a step further, we would be able to see a zero out of this. So what we're going to do is go into your y equals. I would recommend making sure our window is back to default, our negative 10, 10, 1, negative 10, 10, 1. Remember, window is right here. So go ahead and do that. Otherwise, we're going to graph this. We're going to say 4, here's our xt theta button. There's our square. Subtract 3x and add 5. And then we're going to hit the graph button over here. So if we hit graph, I want to show you what this means. Okay, when we found zeros of our exponents, that is when the zero crosses the x-axis. Does this graph cross the x-axis? No, it does not. So if the graph does not cross the x-axis, it is a prime polynomial. And that's what I'm going to put here. Graph the function. Okay. If graph does not cross x-axis, it is a prime polynomial. Why can I not write that? It is a prime polynomial. Okay, so looking at this, it did not graph that or cross the x-axis. So if it can't be factored, we are going to write prime. Again, using our resources, we could double check on every single one of these to make sure that that's true, but especially when they're kind of hinting to us that it's prime, we're going to go ahead and do that. Okay, if it does cross somewhere along the lines, we know that it can be factored, so we're going to have to go through all of our steps and factor it. Okay, so keep that in mind for guided practice 3. Okay, graphing 3a, right away you realize it did not cross the x-axis, so we could see that that was prime. However, graphing 3b, we see that it does cross, which means that this guy is factorable. Okay, so when we do that, look at what we get as an answer. We get x equals negative 1. Remember when we set this equal to 0 and we solved? Look at where it crosses. It crosses that x equals 1, because if we solve this, x would equal 1. So there's our solution. If we subtract it over here, this would be, we would subtract a 5 and divide by 2, which is negative 2.5. And look at that. There's where our answer is. So in a couple sections, we are going to have to go through a couple more concepts like this, but I'm going to show you how nice these calculators are to give us answers. But otherwise, right now, understanding and learning factoring, that one did cross, so we did have just one other nice review for that. Okay, last one. It's a lot of concepts in here, but we're almost done. So we do have to go through this height of a projectile formula because we are going to see it a lot in these next couple sections. It says a model for the height of a projectile is given by height equals negative 16 times squared plus velocity times height time plus the initial height. So there is a lot of variables in there, but they explain every single one of them. T is time in seconds, velocity is feet per second, and height is the initial height of where we were throwing the projectile, and this height is the ending height. Okay, notice how we can actually write that in a quadratic equation. So with that formula in your mind, suppose a cheetah pouncing on an antelope leaps with an initial upward velocity of 19 feet per second. How long is the cheetah in the air if it lands on the antelope's hindquarter 3 feet from the ground? Okay, let's see what information they give us. They give us the upward velocity of 19 feet per second. So they give us the v in the formula. He is pouncing on an antelope, and when you're pouncing on something, you are on the ground. So that means that our initial height is 0. He started from the ground. They also say how long is the cheetah in the air if it lands on the antelope's hindquarter 3 feet from the ground. So our ending height is 3. Okay, we know everything now except time, and that's what they're asking for, how long. So let's go ahead and plug in what we know. We know our height, negative 16t squared. That negative 16 just deals with Earth's gravity, plus 19t, and then plus 0. So I'm not even going to put it there. So again, we're solving an equation. Remember, first step we have to do is go ahead and set this equal to 0. So we have negative 16t squared plus 19t minus 3, and that equals 0. Okay, next step, I know that I have to go ahead and factor this before I do anything. So that means that looking at the coefficient out front, I have to go ahead and multiply these two together. So I have 48 as my factor, and I have 19 as my sum. Okay, so 48 factor and 19 as sum. Okay, I do want to take a step back on this one and show you something that's kind of a nice little trick. So bear with me for just a second because of this negative. We don't like dealing with negatives as lead coefficients. So what we're going to do is we're going to multiply everything by a -1, which really will help our lives. Remember, if we multiply by one side, we have to multiply by the other. But look at what happens. 0 times -1 is still just 0. This is going to give us a positive 16t squared, a negative 19t, and a positive 3. Okay, so what that does is now it changes our factor. Our factor is still a positive 48, but our sum is a negative 19. Okay, so just keep that in mind that we do not like those negatives on that lead coefficient. It's going to make life a little bit unbearable when we're trying to factor. Okay, so other things we know. If our factor is positive and our sum is negative, we know they're both negative. So let's go ahead and start with 4 maybe. Negative 4 and negative 12 gives us negative 16. Close, but not quite there. So maybe we should back up and try negative 3. Negative 3 and negative 16 give us positive 48, and it also gives us negative 19. So there they are. So we are going to rewrite this, and I'm going to rewrite it over here so I have more room. I have 16t squared, and look at this. I'm going to go ahead and say minus 16t, minus 3t plus 3. Okay, so I just flip-flopped them, so I knew that when I factored by grouping, I would have some nice groups, nice commons that I could take out. Okay, so looking at this, we have a 16 and a t in common. We have a t minus 1 left over. Looking ahead, I want to take that negative 3 out. So I have a negative 3 in common because that's going to give me a t minus 1 left over. Okay, so I can go ahead and combine those. T minus 1 and 16t minus 3. Okay, what on earth am I doing? Remember, I am actually solving here. So I'm setting this equal to 0. So I have t minus 1 equals to 0, so my time is 1. But I also have 16t minus 3 equal to 0. So 16t equals 3, and then t equals 3/16. So I have two answers here. Okay, and we're talking about an antelope, or a cheetah pouncing on an antelope. So let's think about what's happening with this cheetah. He's starting here. He's pouncing on the antelope that's over here. Watch this awesome stick figure. Here's my antelope, okay? That's why I'm not an artist. So let's look at this. This 3/16, he is 3 feet off the ground right about here. Okay, so this is about 3/16 seconds. Is that when he pounces on the antelope? No, that's in his lunge. It takes him until right here in order to pounce on that antelope. So it took him not 3/16. Yes, he was at 3 feet at 3/16 of a second, but it took him 1 second to pounce on that antelope. That's a lot of work to get to, oh, it took him 1 second to pounce on an antelope. I understand that. But again, understand this concept that this formula is going to be a formula you see a lot. So final answer in all of this, we are going to make it as bright as possible, maybe bright blue. How long did it take him? 1 second. And of course that turned out red, whatever. Okay, here we go. Last guy to practice. Go ahead and try it. Okay, some really nice things about this problem if you caught it. For one, they set up the problem for us. The only thing they didn't tell us is that it landed on a balcony 218 feet above the ground. So that is our ending height, which meant that we had to subtract it over to this side. The other really nice thing about this problem is all three of these are divisible by 16. So I divided all of them by, for one, a 16, but then also a negative to get rid of the negative off of the front coefficient. And I was down to nothing out front here. So back to old school, what times what gives me negative 18, added together negative 3. And then I didn't have to factor by grouping. All I did was I put my two polynomials together. And then I also went ahead and set them both equal to 0 and didn't really have to think about what I was looking for because I got a 6 and I got a negative 3. And I know I'm dealing with a story problem that is dealing with time, and I cannot go negative distance back or a negative time back. So I know that that ball was in the air 6 seconds. Okay, I keep repeating it, but this is some very high level type of concepts. Graphing calculators sometimes do help you along the way, and I will show that to you in one of the other sections. But for now, please go ahead and give the assignment.